I was actually trying to solve one of those logic grid puzzles yesterday, the ones where you had to figure out who owns which pet based on, like, 5 totally contradictory clues.
Oh, yeah, those are brutal.
Right. And I honestly got stuck in a mental loop for a solid 20 minutes. It is just so humbling when you realize that while you are short-circuiting over a middle school puzzle, we have AI doing
significantly more than that now.
exactly, just a little bit more. Because for this deep dive, we are unpacking OpenAI's massive breakthrough from February 2026, the first proof challenge. And the mission here is exploring how next-generation models, specifically GPT-5 and 5.2, are moving way beyond chatbots to actually solve research-level math problems.
And research level is definitely the operative word there. I mean, we are not talking about textbook calculus where the answer is already in the back of the book.
Right, you can't just look it up.
Exactly. The first proof challenge was 10 incredibly complex research-grade problems. They required rigorous end-to-end arguments in fields like topology and theoretical physics.
Okay, so let's unpack the how right away. Because they didn't just, type a prompt into ChatGPT and ask for a proof. They used a totally new internal reasoning model. And from what I understand, this isn't just the AI guessing the next most likely word anymore.
Not at all. Standard language models operate on probability, right? They predict the next token. But this new reasoning model operates much more like a tree search.
So kind of like a human mathematician at a whiteboard. They explore a logical path, hit a dead end, realize it doesn't work, wipe the board, backtrack, and try a completely different angle.
Yes, exactly that. The model does that entire process internally. It literally thinks continuously for hours, exploring all these branching possibilities and critiquing its own logic before it ever even presents an answer.
That distinction is just huge. It is the difference between improv and actual deliberation. So how did this digital mathematician actually perform?
Incredibly well. The AI successfully solved at least 5 of the 10 problems, specifically numbers 4, 5, 6, 9, and 10. But honestly, the most fascinating part of the whole thing was actually a failure.
Oh, you mean problem 2?
Yes. They initially thought they had solved problem 2, but after the mathematics community reviewed it, they realized the proof was flawed and they retracted it.
Which, honestly, that makes me trust the results so much more. It shows the model can still hallucinate a convincing argument, but it also proves the system is working entirely within the boundaries of the scientific method. Peer review is still king.
Precisely. It is not magic, it's research. And the way they achieved those successful proofs wasn't fully autonomous either. They used this method called collaborative reasoning.
Right, this was the part that felt most relatable to me. It wasn't just set it and forget it. It was a sprint involving human supervision using this specific loop of generate, solve, and refine.
Exactly. Think of it as a workflow. First, you have the generate phase where the model acts as an idea generator, proposing high-level approaches. Then solve and verify, where it pursues a specific seed idea. But here's the kicker. It critiques its own work to find gaps.
And if it finds a gap, it moves to refinement, rigorously revising the argument until it holds water. It sounds so much like a principal investigator guiding a really talented grad student.
That is a perfect analogy.
The human PI says, hey, this approach looks promising, dig in here, or check your logic on step 3. But the AI, is doing all the heavy mental lifting.
And the lifting was heavy. Take problem 6, for example, which dealt with large epsilon-light vertex subsets.
Which sounds incredibly dense.
Yeah.
But the solution involves something called a one-sided matrix barrier argument, which is basically a structural filter, right?
Yes. Think of the proof like trying to build a bridge across a canyon. You have thousands of mathematical variables you could use. The matrix barrier argument is a way for the AI to figure out exactly which stones
are load-bearing.
Exactly. It filters out all the noise to find the essential structure holding the weight of the proof.
So it applies a structural filter to chaos, so you can focus on the big picture.
Yeah.
Which, honestly, is exactly what our partners at Embersilk are doing for business automation.
Oh, absolutely. Same exact principle.
Because this deep dive is sponsored by Embersilk. If you need help with AI training, integration, or just uncovering where agents can make the most impact for your business or personal life, you need to check out embersilk.com. They're the ones who help you find your own load-bearing solutions.
Which ties perfectly back into the bigger picture of discovery here. We are seeing a total shift in how we evaluate AI. Moving from standard benchmarks to frontier research, the whole goal now is to stress test the model's ability to sustain long chains of reasoning.
Right. I read a quote from OpenAI researcher James R. Lee about this. He talked about the experience of watching a model get tangibly smarter day by day.
It really is an incredible time to be in science. Think about the implication of finding structure in complex systems like we saw in problem 6. If an AI can do that for abstract topology, it can do it for biology.
Understanding protein folding or complex particle interactions in physics, that is the real promise here. These tools are not replacing scientists, they are accelerating them.
Exactly. We are looking at a future where we might solve things like energy efficiency or disease pathways in a fraction of the time, all because we have these incredible reasoning partners.
It is so optimistic.
Yeah.
Which brings up a fascinating thought to leave you all with. If AI can now act as a true reasoning partner for highly abstract math, what other quote-unquote unsolvable problems are suddenly completely within our reach?
I think we are going to be very surprised by the answers over the next few years.
I totally agree. Well, if you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.